Hello, and welcome to the session today. Monitor all your things. It's going to be with myself. So my name is Brian Dennehy. I'm the Director of Engineering for the AWS CloudWatch team, based out of our Dublin office. I've been in Amazon for over 11 years. I originally joined as an engineer on the shopping cart team. And then in 2008, I moved into the monitoring team just before CloudWatch was born. Didn't even exist at the time. And I've been working there ever since. And I now run all the teams in our Dublin software development office. And I'm going to be joined on stage by Christopher Darlston, who's development lead at BBC. I'm sure you've all heard of the BBC, one of the world's biggest broadcasting companies. So let's start with some numbers. So each month, CloudWatch processes 100 petabytes of log data, triggers 3.9 trillion events, and ingests 1 quadrillion metric observations. Now, I admit, I didn't know what a quadrillion was. I had to look it up. It's actually 1,000 trillion. So all it kind of says is that we really care about monitoring data. And more to the point, you guys, our customers, really care about monitoring data, which is why we're constantly seeing an ever-increasing volume of telemetry data coming into us. So that kind of brings me to the question, why is monitoring important? Well, first, it's about giving yourselves as developers and operators visibility into how your applications and resources are doing. How are they performing in production? Is everything working? Is your customer experience good? And having metrics gives you confidence that when you deploy change, such as new versions of software, or patches, that it's working in production and your customers aren't seeing any adverse impact. And the reality of today's way of doing business is it's really important to stay ahead of any adverse customer impact, because the internet is a perfect broadcasting medium. So if you have some adverse issues, you can bet your bottom dollar that customers are going to talk about it, broadcast it on social media. So you really need that visibility to stay ahead of that. And the customer experience is increasingly important. Think about your own selves. As a customer yourself, how many times have you abandoned a purchase on an online website because their website was too slow? Or you've deleted an app from your phone because it crashed a couple of times? And bad customer experiences are viral. You'll tell others about a terrible customer experience much faster than you'll tell them about a great one. And customers have so much choice now that you can't afford to have a mediocre experience. So all this to say, application performance and uptime has a direct correlation with your business bottom line. Because customers have so many different options, and they'll just walk away and move to someone else. So while monitoring is still very important, how you monitor today is very, very different from how you maybe monitored 10 years ago. There are different requirements influenced by infrastructure changes, different development philosophies, and heightened customers' influences. So as you migrate your on-premises applications to the cloud, either via lift and shift, or maybe by re-architecting your previously monolithic system into microservices architecture, you have to think about monitoring in a different way. The on-premises tools that you used to use may need to adapt to be cloud native. And moving to a microservices architecture changes from a relatively few monolithic components to a relatively large quantity of highly distributed, perhaps multi-region components that are all running and producing telemetry data, each producing its own sort of telemetry data. And that's helping to drive an increase in the amount of monitoring data that's being used. Additionally, there's a proliferation of new devices that perhaps previously weren't in the realm of IT management. Things such as IoT devices, where we're seeing folks use devices in their connected home or connected energy. We're seeing factory floors have a lot of IoT devices producing information, sensing information from all those different places. And all those devices need to be monitored and managed and produce their own telemetry data streams, leading to an explosion, really, in monitoring telemetry data. And with the cloud, you also have an increasing use of on-demand resources, whether they be on-demand EC2 instances, or auto-scaled EC2 instances, or perhaps even Lambda functions where you don't even manage the infrastructure yourselves. And these on-demand resources are increasingly ephemeral. They turn over much quicker than they ever used to. In the old days, you used to get a server, and you have it running for about 10 years until you decommission it. And nowadays, you might have a container that runs for just minutes, an order of minutes. Each producing its own set of telemetry data that you need to collect and understand to help you run your applications and services. And last but not least, one of the key philosophies that we're seeing, perhaps all of you are already doing it, but at AWS, we've always followed this model, certainly since I've been with AWS, which is over 11 years, is the continuous integration and continuous deployment models, where now we're pushing code. You're just writing the code and it's going straight into production. And of course, in order to do that, we've developed suites of automated test pipelines to make sure, hey, is everything working? Is all the features still working? Run through all those tests. But not only do you have to test before you get into production, it's increasingly important to make sure that it's constantly working in production. So you also need to monitor it post-continuous deployment, make sure your customers aren't seeing an adverse impact from a change that was delivered. So those are some of the differences in monitoring, but of course some things are not changing. You still need full stack visibility, and you still need real-time alarming and alerting capabilities to help you know when things are going wrong. Now, CloudWatch is here to help. So CloudWatch is built to handle high scale. And just like with AWS services, other AWS services, operational excellence and security are our #1 priorities. And our operational performance has been strong over the past number of years. In fact, all of Amazon and AWS services use CloudWatch to monitor Amazon. So we're handling all of the data coming from our Amazon service teams. So we really do understand that it's really important to be high scale and highly available all at the same time. And of course, CloudWatch is cloud native. It's built in the cloud, it's part of the cloud. And all of the AWS services publish telemetry data to CloudWatch for you to consume without you having to do anything. So you provision any AWS resource, and you're going to start seeing telemetry streams in CloudWatch. It's going to help you understand how that thing is performing. And CloudWatch provides a single solution for both metrics and logs and helps you coordinate between those two things. Because we often see that solving and troubleshooting issues is really a combination of metric data and log data and perhaps other types of information. And then perhaps finally, on this point, CloudWatch gives you the opportunity to automate your monitoring. So you can use SDKs, APIs, command line interfaces, and even CloudFormation templates and so on to automatically provision your monitoring as you add new capabilities and new systems and services. So let's go one level deeper and just talk a little bit about how you get to this end state of operational readiness. First, collect all your data, whether it be metrics or logs. And metrics provide high-level signals. They're very cheap, they're fast, you can see a lot of information on a single line on a graph. And they help you understand, is something wrong? And then once you have metric data, very often people will build dashboards, right? That'll be the standard way to interface with a monitoring system. You go build a dashboard, take a look at your dashboard, all the graphs that you want. And when something goes wrong, you'll visit the dashboard and start your troubleshooting process. And of course, graphs are great, but they're really for humans to consume. Humans are the ones who make the most sense out of graphs, the data visualizations. We make a lot of sense out of that extremely quickly. But you can't watch every graph 24/7, 365, especially in the world where the number of things to be measured is exponentially increasing. So you need real-time, high-performance alarms to help you. And with CloudWatch alarms, not only can you act as close to real-time and get notified, but you can also take remediation steps, such as auto-scaling your EC2 fleet to add compute power when you don't have enough to support the demand you're seeing. And when you're deep diving for troubleshooting and post-mortem analysis, you want to analyze your data often in log files, and so you tend to use log files for that. And deep dive into the logs with complex queries to really deeply understand what exactly is going on. So don't take it from me, but we're going to see it all in action from the BBC. So it is my great honor to welcome to the stage Chris Darlison from the BBC.
Thank you, Brian. So who am I? I'm Christopher Darliston. I've been at the BBC for the last 7 years, since the BBC moved up to the new Media City campus. I work in the interactive TV space, and I take it you all know who the BBC are, right? Yeah? Public service broadcaster in the UK, the largest broadcasting organisation in the world. So, interactive TV apps, I've worked on them. That's getting video out to our audience members, getting sports data out to them, or getting journalistic content out to them. So here's an overview of the BBC Interactive TV application. It can be a connected experience, whereas you've got an interactive channel back, and you can load additional information from things like Glastonbury Music Festival, getting the different stages that are there and being able to watch the different bands that are on. Whether that's looking at Wimbledon, tennis, looking at the different courts that they have there, or whether it's the Olympic Games and getting to watch your favourite sport that may not be on linear TV at that time. But we also have an unconnected experience where we may be able to push out data to you across as a side channel to the broadcast bandwidth. And that's a lot smaller and is required by a lot of people to be able to find things like weather data, the lottery results, and even local news for them. So it's a very important service that's used by many people across the UK all the time. So I want to talk a little bit about our architecture first, how we use CloudWatch, and then I want to tell you a little bit of a story that we have. So, looking at our architecture, we have really 3 data hubs in our unconnected red button experience. We have, off to the left of this slide, which is not really that interesting for what we have here, is where our other teams work with journalists. Journalists write their stories, and they then get uploaded to our AWS estate. You can see that in our AWS estate, we have 2 different VPCs here. We have the main VPC, where that receives in the data from those upstream systems, and then does some transformations on those, taking the content that is shared across the web, the connected experience and the unconnected experience, and then, in this instance, converting it into a format that is able to then be bandwidth compressed and then sent out as a side channel to the video. We then, once we've finished working with that, we use SQS, SNS, and an S3 bucket to be able to then take that data and send it through to our data playout VPC. Now, we've deliberately done this so that in our data playout VPC, we can lock down who can actually access it, so that only if you're coming from the main VPC will you be able to actually send data through to the data playout VPC. In that data playout, there is nothing that is internet focused or internet facing, because security is paramount to us. If someone puts malicious content into our broadcast stream, then that goes out to millions of TVs, all across the UK, and that's just something that we can't comprehend. We have a carousel injection system which takes all of the different upstream systems, looks in S3 for its data, gets a message from SQS and SNS, and is then able to process that, verify the data, make sure everything is correct, and we then start a synchronous piece at this point. writing the data to EFS, which gives us a central store for that and a unified place, and then sending it on to our carousel creation system, which is then able to talk over a direct connect piece onto our on-premise systems. So that's the bit that we have on the right-hand side. We have two different on-premise data systems that we use, again for redundancy, because it needs to happen, it needs to be there. You know, when you have journalistic content be created, you want it getting out on air as soon as possible and in a secure fashion. From all of these systems, we then collect data. And you can see that we have in the middle of the slides CloudWatch. You know, I've not put it in either of the VPCs because it's there. Everything that we talk to brings us data back and stores it in CloudWatch. Whether that's our upstream system, whether that's our AWS, Lambdas, our EC2 instances, whether it's data from our SQS, SNS, S3, or whether it's actually even data from the right-hand side on-premise. We need to know what's happening on-premise, and although we have people monitoring those actual centers, we also then ship those logs back up to CloudWatch. So it gives us a central place and one place to look for this. Here's a bit of a snippet showing the CloudWatch agent setup that we have on one of our EC2 instances. You can see we've got three sections to this. We've got a metrics section where it tells us which of the information about that actual instance we're collecting and what we care about, whether that's memory, process, disk, or CPU. We have a logs section. So this is for one of our applications, our link manager application, and you can see that we're picking up the log files from that, and we're then shipping those off to CloudWatch as well. Lastly, we have in there, we have the agent line at the bottom, which allows us to understand what's actually CloudWatch agent is doing, and we can have some information for that. Oh, go forward a bit too far. There, right. So I talked about sending metrics. I talked about sending logs. Logs, are human readable. That really doesn't help when you want to do dashboards. So being able to extract the important information from those log lines using custom metric filters is vital for what we do. And you'll see that in the next couple of slides of what we have. The top custom metric filter is right from our ingestion system, and it tells us how long it takes to inject a test scene into our pipeline. We'll use that because we need to know end-to-end how long does it take for things to flow through our system. At the bottom, the filter there is from one of the platforms that we support. So there are multiple broadcast platforms that the BBC publish out to. And so for each of those, once the data has been injected into the top of the system, flows through our AWS estate, and then goes out to broadcast. It is combined in with the video, the audio, and then sent to a broadcast tower or sent up to a satellite. We then receive that data just as our audience do, and we look for the test scene. We pull out the data of the test scene, and then we say, how long has it taken? So that way, we get end-to-end, and we understand what's happening on there. This gives us a typical day of monitoring. So we have a dashboard. There's a little bit at the top of it that tells you how it works, so that someone coming along to a dashboard, they may not have seen it before. There's many graphs. There's many bits of information on there, but Why did someone create it? What was the intent of this dashboard? Well, here's a bit of information at the top so someone can read it. If they know what they're looking for anyway, they can scroll down. But on the top left, we have the time that it takes to inject that test scene. The other three graphs that we have on here are the time that it has taken for each of the three platforms. There are more that would normally show on this graph, but we've limited down for what we see here. And what we can see on here is there is a product aspiration in blue. How long does it take us to get content right through our publishing pipeline? There is an acceptable level in green. So we always want to be as quick as we can, but there's some acceptable levels. Or there's a red area, and that's where it's starting to take a bit more time. And maybe that's something that we need to have a look at. So on a typical day, you see fluctuations. It's not a flat line. It tells you that things are real. There is always a bit of variation in here. On top of this, as Brian was saying, dashboards are great, but you need to have alerting in there. So here is one of our CloudWatch alarms, and this is telling us about our queue depth. And because we queue in front of various parts of our playout system to protect that, we need to know, is that queue growing? If it gets to a size that's too large for us, then we need to alarm. And this is hooked up to our on-premise internal monitoring system, which is supported by our 24/7 operations team, and also can email out to our out-of-hours support for this specific area. You'll see also in here that in the description, we link through to what is our runbook, so that when the alarm fires, there's a quick way of getting to the pertinent information that is related to this alarm. When you have many different systems, alarm happens. How do you find out what that alarm means, how significant it is, and how to look to see which component and what you need to do to actually get rid of this alarm? So you saw an example of our dashboard, and let's picture a weekday morning. On this particular morning, I came into the office around 7 a.m. UTC on this graph. It was in the summer, so I wasn't in that early. The graph looked like this, which, as I showed you on the previous graph, gave me some concerns. Nice flat bit, yeah, it's in the green, that's not a problem. But just around 7 a.m. UTC, we see a big spike in our end-to-end time. And this is across all of our platforms. So there is something that is happening that is not platform specific. But where do you start? I talked about an upstream. I talked about our AWS estate. And I talked about our on-premise system. So how do we look at this? You have a large problem to solve, so let's split it down. Let's understand, and because it's important what's happening to our audience members, let's start at the right-hand side. Let's start closest to our audience and see, are there problems there? So we have a set of graphs that tell us about our tunnels, our VPN tunnels across our direct connect. We talked about security and how that's important to us. So although we have a direct connect from AWS through to on-premise, we also want to make sure that we have some security on top of that. Now, you've got two vertical lines on this graph. The one on the left-hand side is about 7 a.m. UTC. And the graphs that we're going to show for the next little bit has the entire day, but really we're focusing at this point around that left-hand annotation. So we can see that one of our 4 tunnels to our data centers is down, but That's not a problem. We've still got 3 others. And you can see that we've got data transfer actually occurring between AWS and on-prem across 3 of those VPN tunnels. So that's not a problem. We don't have an issue between our AWS estate and on-prem. So, okay, great. Let's not worry about that for the moment, and let's move up and see, actually, is something coming into us? Because we said that we had queues in front of us, so have they been building up? So I've got three different graphs that we have here. The approximate age of the oldest message, number of messages visible, and then number of transactions successfully processed. So if we see our queues building up, the one on the top right, the approximate number of messages visible would be larger. Now, typically, we see this down in the single digits because the idea is to get the data in, process it, and then send it forwards. So that was still down in the single digits. It hadn't actually fired an alarm at this point because it was still within our tolerances. You'll see that as we went through the day, we did actually fire quite a few different alarms there. We also want to know that how old is the message on the queue? Because even if you only have one message on the queue, if that message has been on the queue for a long period of time, then maybe you're not processing your queue. So your queue depth is perfectly fine. You don't have too much waiting, but it's been waiting for too long. So at that point, our age of our oldest message, again, is quite good. So that's why we haven't had an alarm there. Looking at the last of those, transactions successfully processed. Well, we've only got a small snippet of time here, but if we actually looked at this over a long period of time, you would see that it would be hovering at the same level, on the left-hand side. So actually seeing that start to dip down at this point is saying that something in our AWS estate is not processing the transactions quickly enough. So it's not that we're not getting transactions in. It's not that we're not actually sending data through to our on-premise, but there should be a problem in what is processing our transaction, which, given that this is for our injector, which is in the data playout VPC, means that we've even isolated which of our VPCs is having an issue here. Now, that identified down to which component, but the problem that we had is that was where, at that point in time, our dashboarding was limited. We'd exhausted the dashboards that we had. Now, we knew we had a lot of log files, but when you're in that crisis period of a war room and you think, well, how am I going to trawl through all of these logs? What's a pertinent piece of information to us? So along with my principal engineer at the time, we sat down and we went, what can we do to actually get that data visualized for us? Because as humans, actually looking at graphs allow us to see trends a lot easier than looking through log lines. So this dashboard was actually created on the fly during the incident, and then after the fact, we use it and we keep it there, and has become an addition to our dashboarding. But prior to 7 a.m. UTC, we didn't have this. This tells us about the time it takes us to download a file, again, a duplicate of our input queue, and then some execution time. You can see, hopefully you can see on here that prior to the left vertical line, everything's quite low. But just in front of that vertical line, things have gone wrong. And they've jumped from an order of 0 to 40K. That's not good. And so we were able to work with the people that we needed to at that point to investigate where that problem was, because it identified specifically within our application, what our dependencies were and where we were having that issue. And so we're able to talk to the right people, get those people actually working on the problem with us, and you can see over the course of the next few hours, we're able to solve that. You can see that the execution times came down, and we were then able to process through our input queue. And so by about 6 o'clock in the evening, we're actually now running back to a healthy state that we were before I came in the morning. Now, across all of that, we didn't lose any of the data. It was all there. It was all either stored in queues or stored in our S3, and we were able to process it. It just meant that it took a little bit longer for us to actually get it out onto the broadcast. Circling right back to the start, I showed you the monitoring view at around 7 in the morning. I've showed you the dashboard that we created. And so I wanted to show you what this monitoring view looked like at the end of the day, and allows us to see that actually we have got back to a situation that is healthy for us. So what did we learn? Firstly, it was a complex problem. So split down your problem space. See ways of being able to segment where you need to look, and tackle those to start with. Try and eliminate the areas that aren't the problem, so you can then start to focus on where the problem is. Logging. Log as much as you can, because you never know when actually that might be useful for you. If we hadn't been doing the logging that we actually had within that component, then we wouldn't have been able to create the dashboard that we needed to. And then I asked you the question, do you have the right dashboards today? The answer should be, it doesn't actually matter, because you have what you need today. And if you don't have what you need today, then what you can do is look through your logs and create the dashboard that you need tomorrow when you need it tomorrow. And if you only need it for tomorrow, create it for tomorrow, use it, and then get rid of it. But you may find that actually it is more useful for you at that point, and then you keep it. So CloudWatch allows you to quickly make those meaningful filters, make those widgets, create those dashboards, to instrument and investigate what you're needing to do at that time. So why do we, as the BBC, use CloudWatch? Well, our services just need to work. When you pick up the telephone, you expect, for those of you that are old, you had to pick up a telephone. Now, when you actually take your mobile phone out, you expect there to be a dial tone. You expect it to just work. And that's the same thing for if you turn on your TV. You expect to get sound. You expect to get a picture. And in the UK, people expect on a BBC channel that if they interact with it, they'll then get interactive data. And so being able to get our journalistic content out to everyone is very important to us. So Amazon CloudWatch, it allows us to aggregate our log analytics in one place, to monitor what's happening and have the flexibility to work and instrument our applications if there is a problem. I talked about us having 3 data hubs. Can you imagine having to connect to one data hub to look at the logging in there, and then connect to a different data hub to look at the logging in there, and then go somewhere else? So by being able to bring it into one place, it allows us to work more efficiently. And it allows us to move more time back to focus on innovation. Because if you're logging it, you can create it when you need it to. So thank you for listening to my part of the journey. What I'd like to do is hand you back to Brian. So thank you.
Thank you. Thanks, Chris, for sharing that deep dive on a war story. I'm sure we all have war stories. I know I do. Pretty interesting to see what you've done here. So at CloudWatch, and really as Amazon as a whole, we're always looking for ways to reinvent and simplify. Trying to engage with customers and figure out what the guiding direction is for the future and our new products and releases. And this is why I'm really excited to talk about today something called CloudWatch Automatic Dashboards. So a few days ago, we launched this, maybe last week. And CloudWatch Automatic Dashboards makes comprehensive monitoring available for everybody, whether you're an experienced AWS user or you're just first time at the system and you've never used it before. And we've always urged our customers to monitor critical metrics and set up dashboards to help you troubleshoot and root cause things when they're going wrong, just like we do internally at Amazon every single day. And with automatic dashboards, AWS is automating the collect and monitoring aspect and guiding you towards effective monitoring practices and providing great defaults right out of the box without you needing to do anything. So in a little bit, we're going to go through it in a bit more detail. But before we do, I want to share a bit on why we built this new feature. So you saw from Chris's talk how the BBC collects metrics that monitor infrastructure, system, and application health. And if you recall from an earlier slide, I mentioned that here in Amazon, we use a lot of metrics, and metrics are really crucial to the visibility that we get into the operational performance of our systems. And we collect a lot of metrics, and it all gets stored in CloudWatch. But with so much choice and so much options of things to look at, how do you get started? So if you log into the CloudWatch console, what should I look at? And to get started with operational monitoring, first you have got to understand all the services. And there's so many new services all the time that it can be a little bit challenging, like which metrics are important. And not all metrics are equal. Some are more important than others. Some are more important for your different use cases. So you got a lot of information to get started. And then you got to log into the console and build your own dashboard or use a CloudFormation template or code or a script to create the dashboard that you need. So there's quite a lot of other gotchas, like which statistic do I use for the particular metric in question? Which works best for latency or for error count or whatever it is? So we wanted to help our customers. So we started thinking about how we're going to do that. So AWS service teams, we have a long history of operational performance and using monitoring systems to do that. Over a decade of delivering highly available AWS services at high scale. And some of the advantages of CloudWatch automatic dashboards are, well, first, they're automatic, right? So you don't have to do anything. There's no setup required, no configuration needed, no code to be written, no CloudFormation template to be written. It's all there. When you log into the console for the first time, you're going to start seeing useful and valuable information. Second is, they're smart. So we've gone and investigated what are the most commonly used metrics for the various different AWS services, and we've surfaced those right up top for you to help you get started with what's most popular. And we've also worked with the service teams to ask them what is the most useful of those metric data and put those right on the screen in front of you. And third, they're dynamic. And that means that they stay up to date with your running infrastructure. So we interrogate what you're running and then produce a dashboard that represents what you're currently running, which is often the most important thing. What's going wrong right now? I need to know what's running. And the dashboard is about your currently running infrastructure. And then finally, they're granular. So it's not just a high-level overview, but it also gives you opportunity to drill down through several different layers to help you start your troubleshooting process and hopefully finish your troubleshooting process by identifying and pushing a fix. So I'm going to brave the demo gods and give you guys a live demo right now. So can we switch? There we go. All right. So this is a CloudWatch automatic dashboard. So before we get started on the demo, maybe I'm going to give you a little backstory, right? So today I'm an application owner. Say I run a website. And on my website, I've got 3 different applications. One is called Hello Retail, and that's the front website of my system. I also have an order pipeline that allows customers to process the order, tell me where they live, where they want the chip to, and execute the payment. And I have a shopping cart system that lets customers decide what they want to buy and stick it in a shopping cart for later use. You might recognize some of those components. So that's the sort of frame of reference that I have here. So I'm a service owner, and I come to the CloudWatch dashboard, and instantly I can already see some valuable data. So up at the top left, I've got alarms, a summary view of alarms organized by AWS service. So you can see I've got various different alarms, DynamoDB, Lambda, API Gateway, billing, classic ELB, and so on. And I'm using all of these services in my application. And you can clearly see, at a glance, something's not quite right. So I've got some issues going on in Lambda and DynamoDB. And then to the right of that, you can see recent alarms. And these are the most recently transitioned alarms. And they're prioritized by urgency. So as you can imagine, the ones in red are the most urgent because those alarms are currently firing. And I probably need to go do something about that. So before I go do something about that, I'm just going to show you a little bit further down the page. So down here, we've got a cross-service dashboard. So what this is showing is, for all the services that I'm using in this account, a couple of important metrics. These are the metrics that I told you already are the most popularly used metrics for that particular service. So you can see I've got API Gateway, I've got ELB, I've got CloudFront, I've got CloudWatch events, and so on. And you can already see some useful and interesting data, and I didn't have to do anything. I just get it right out of the box. So if you recall at the start, I said I had 3 applications: Hello Retail, Order Pipeline, and Shopping Cart. But right now, I'm really interested in the Hello Retail application. And so we use a mechanism, I don't know if you all use it, something called resource groups. So resource groups is a pretty useful way for you to inject some context over the resources that you're using. So you can just tag your resources whatever way you want, and then you can pull in those tags into a group. And you can kind of use that grouping to help you filter. And you can use that right on the automatic dashboards. So once resource groups exist, we're going to find them, and we'll give you the ability to filter by that. So I'm primarily interested in the Hello Retail. So right now, I'm just going to open this resource group drop-down. I can see the 3 resource groups that I'm interested in, and I'm going to choose Hello Retail. It's going to filter the dashboard. So that's filtered the dashboard now, but it's only showing the resources for that Hello Retail application. So I've narrowed the scope, similar to what Chris said earlier on. Narrowed the scope of my problem space, and I can still see an issue with Lambda here. Before I go into troubleshooting, I'll just give you another little interesting piece here, is that you've got this default dashboard here. So you can associate a custom dashboard. This isn't fully automatic, but you can associate a custom dashboard with your resource group. So when you filter by resource group, you get the default dashboard that matters to you on the screen, as well as the cross-service dashboard. So in this case, I've got some order metrics, I've got some order rate, I've got some shopping cart, and I've got some CPU utilization graphs. Now for me, these are the most important metrics that I want to see when I look at the Hello Retail application. And you guys can set that up. It's pretty simple. So I guess we better get started at figuring out what's going on. So we start with the Lambda here, and all of these are clickable links. So you can click on Lambda, and it's going to take me to a more detailed view of the Lambda system, my use of Lambda. So I click on Lambda. You can still see that Hello Retail is selected at the top. So we remember that you want to look at Hello Retail all the way through your navigation process. And now I can clearly see there's a few things going wrong. I've got my duration, which is kind of like a latency, we would call it. It's kind of gone up. And my errors. There's obviously something wrong going on with errors. And so here I am, right? I know something is wrong, but I'm not yet quite sure what's wrong. So I need to dive a little bit deeper. I need to dive into some log data. Before I do, I'm going to just narrow my focus again. So you can click on the legend of the interesting color you want. And then on all of the graphs that you're looking at, it's made the other one disappear. So you can just focus on what's common. And that's a really common use case where I want to look at a very specific thing across a lot of different graphs all at the same time. So let's look into the logs, shall we? So you simply click on the 3 dots, go down to View Logs right here, and I'm going to open up the logs for that Lambda. So the Lambda logs are automatically flowing into CloudWatch. When you can just put console.log into your Lambda function, and it will flow into CloudWatch for you too, right? And you probably heard the announcement yesterday, I believe it was, and you can see right up the top, we've got CloudWatch Logs Insights. So this is a new feature. So today, I'm just going to quickly drop in here. I'm not going to do too much on CloudWatch Logs Insights, but what you can do is it's a powerful query mechanism to let you interrogate your logs. So I'm trying to find an error here, trying to find something that's going wrong. So I drop into CloudWatch Logs Insights. I don't need to do a fancy one. I'm just looking for error. Let's run the query and see what happens. Just takes a couple of seconds. I hope. There we go. So it's already queried the logs for errors, limited my set to errors, and I can already see valuable information. So now, for example, I don't know if you guys can read it from down there, but this says I've got an error reading table prod-prod catalog 1. And I know that my Lambda function is calling a DynamoDB table, and that's the name of it. So now I know there's an error with my Lambdas, and I know it's an issue calling DynamoDB. And there's a second log line in here, which is provision throughput exception exceeded. So now I know I'm calling Lambda function, I know which DynamoDB table it is, and I guess I don't have enough provision capacity to process the traffic that I'm suddenly getting. So I better go and fix that. So now I'm going to pop back to my automatic dashboard. And just up here, you've got a little navigation button. So I can open this navigation. And once again, all the services that I'm using for the Hello Retail application are listed in this dropdown. And I can see there's something going on in DynamoDB. So I'm going to pop down to DynamoDB. Hello Retail remains selected. And now I'm looking at the DynamoDB tables that are used by the Hello Retail application. And I can see there's an issue with get item average latency. I can scroll down a little bit, and I confirm that I am getting read throttled. So there's something I need to do here. I got to fix this issue because I'm getting throttled. And now down at the bottom of each of the service-specific dashboards, you'll see a list of all the DynamoDB tables that are represented up here. And these are clickable links. So when I click on one of these links, I'm going to get transported to the DynamoDB section of the AWS console with the specific table already selected to help me troubleshoot this issue. So I'm going to pop in to the right one. It opens up the DynamoDB console. The prod-prod catalog 1 table is already selected. I'm going to swing over to capacity because I know I need to increase capacity. And oh my God, someone has set this to 1. That's obviously a mistake. That should be 50. So let's set it to 50. Save that. So now I'm instantly fixing the issue. It takes a few seconds to apply to Dynamo. It has to distribute all the records back out to all the Dynamo stuff. So you just have to wait a couple of seconds here for that. If you just bear with me while it applies. But as we're waiting for that to apply, I'm going to switch back here. So that's applied now. And now we're going to switch back to the overview and just explain a little bit, just summarize what we just did. So we navigated to the CloudWatch automatic dashboard. We noticed something was in alarm, was in Lambda. We're able to filter down to the particular resource group, which really represents my application, the resources that run my application. I was able to quickly deep dive into a Lambda-specific dashboard, identify that we were seeing errors. Then I was able to dive into the logs for that specific Lambda, all automatically populated for me. And I was able to log into the new CloudWatch Log Insights query system, find the errors, use those error log lines to figure out which DynamoDB table was causing an issue and why it was being caused. I was then able to navigate to the DynamoDB console, or section of CloudWatch Automatic Dashboards, confirm I was seeing read throttles on the particular table in question, and from there, jump to the DynamoDB console and ultimately resolve the issue. So that'll just take a few minutes to work through the system, and then it'll flip back to green again whenever it's all working again. It just takes a few minutes to get through. So what I'd like to do now is flip back to the slides, if you guys don't mind. So what I'd like you to take away is just a few little things. First, collect everything with ease. Collect all your data. Use defaults for building operational visibility. It's really important to collect as much telemetry information as you can, because you never know when you need it. Second, correlate your metrics and your logs together. Together, they are a powerful troubleshooting mechanism. Metrics tell you something is wrong. Logs help you figure out what exactly is wrong. And third, automate your monitoring with new CloudWatch operational dashboards. So there's a few other things to learn. So just a few new callouts. You may or may not have heard of some of these things. Just a few days ago, we launched the ability to do alarms on metric math expressions. It's a pretty important new feature. Yesterday, we launched CloudWatch Log Insights, powerful querying features. And there's a session later on today in the MGM Grand at 6:15. So if you're really interested in getting more deep depth on the log insights that I just gave you a tiny little piece into, please do attend that session. It's going to be really exciting. A couple of months ago, we launched the ability to integrate CollectD and StatsD metrics into the CloudWatch agent and publish those to CloudWatch, making it easier than ever for you to collect data. Again, a couple of months ago, we released the ability to snapshot graphs. So every picture that you see on that screen, you can write a query to CloudWatch to get that graph image, to save you from doing your own graph images, and you can then push that into your internal wikis or your internal intranets and so on. And we also launched events support for AWS organizations. And additionally, I'm not going to read all these sessions out. You can read them all yourselves there. We've got a bunch of CloudWatch sessions. Please come along, learn more about it. And all that remains really is two things. First, thank you all for attending on behalf of myself and Christopher. And second, please complete the survey in the mobile app. Really appreciate your time. Thank you so much.